Hello, I'm Padma Mallikarjunan. I am an enterprise support manager at AWS, and I am based out of Austin, Texas. Welcome to AWS Supports You, where we share best practices and troubleshooting tips from AWS Support. Joining me today is Tom Coombs and Yuri Rosenberg from AWS. Can you give us a quick introduction, Tom and Yuri?
Thank you, Padma. I'm Tom Coombs. I'm a technical account manager from Zurich, Switzerland, and I work with our enterprise support customers.
And hi, I'm Uri Rosenberg. I'm a specialist technical account manager for machine learning and AI out of Israel.
Thank you for joining us from across time zones. Everyone, in today's topic, AWS supports you getting started with machine learning. We will also discuss AWS Enterprise Support and how it can help customers in getting started with the AWS suite of ML services. Before we get into the details, a quick note to our attendees online. Please use the chat window on the right-hand side of your screen to ask your questions and share your thoughts throughout the episode. We look forward to hearing from you. Tom, can you walk us through what we are going to be talking about today?
With pleasure, Padma. Thank you for the introduction. We will be talking through machine learning at Amazon. We'll be talking through the machine learning stack at Amazon. So to explain how customers can use that stack to do their own machine learning projects. We'll be demoing how to integrate those products, and we'll be talking through the machine learning process and how Amazon SageMaker can be the linchpin to giving you the tools you need to get into machine learning faster. We'll be giving a demo on how to use Amazon SageMaker and Autopilot to accelerate your projects. And then we'll go into some details on how AWS technical support can help with our new ML proactive services. And then we look forward to hearing your questions. So let's get into it. Machine learning went from being from a new technology to mainstream extremely fast. For a long time, the technology was limited to major tech companies and hardcore academics. But then things began to change when the cloud computing made this all mainstream, in that cloud computing power as well as data became available. Quite literally, machine learning started making an impact across every industry. It's moving from the periphery to being a core part of everyday business in many, many industries. Amazon went through its own multi-year machine learning journey. Amazon has been applying ML technology to such things as personalization and supply chain for more than 20 years. ML has become an integral part of Amazon. We've improved, we've innovated in ways such as natural language processing, for example, in products that you might use in your house, such as Alexa. We've also delivered technology for autonomous flight with Prime Air drones. This was a big culture change for us at Amazon, and we feel it's something that we can help every organization do. Our approach to machine learning has resonated with many of our customers. More than 100,000 people of our customers use AWS for machine learning, from the largest enterprises to the hottest startups. Companies are working with us to build solutions which are core to their business. And AWS puts you in a good place to do this, in that we have the massive storage and compute as an undisputed leader in this field. We also have a strategy on implementing data strategy. ML relies on a foundation of compute and storage, and AWS has these services to back that up. We've often found that machine learning talent can be a blocker. Lots of people have development teams, so did Amazon, but we needed to change the way we think for machine learning. AWS has helped many of our customers do this with applying machine learning technologies such as Deep Racer. Deep Racer is a race which allows you to race using machine learning without actually knowing that you're learning machine learning, but you don't need to come into it knowing it. Our expertise, I think we've already talked about when it comes to the 20 years. We do this by reducing complexity. We do this in many products at Amazon. Amazon SageMaker, for example, increases your productivity by giving you reusable tools. Whenever our customers start an ML journey, we always say that they should start with a business value, not just the coolest technology, albeit we like using them ourselves. So how do you get started on your journey to ML? AWS machine learning uses horizontal use cases with AWS Services, for example, to solve business problems for all verticals. We also have vertical solutions in areas such as health science and manufacturing. If none of these fit and our vertical solutions don't fit, you can build your own models with Amazon SageMaker. We can help you do that. But if we step back a little bit and we think of the general process for machine learning, it always starts with good data. It starts with good labeled data. It starts with the data preparation, and you feed that data into your machine learning algorithm. Then you need to train it. Then you need to tune that. Then you need to deploy it, maybe deploy it at scale. And our machine learning stack can help you with this. So with that, I'm going to stop for a moment and just ask if there are any questions from the audience.
Hi, Tom. Thank you. There's one question online. It is whether these episodes are recorded. Thank you for your question, RK, LBHB, DNFL. These episodes are recorded, and I will post the link on the chat window here shortly. And please post any other questions you all have on getting started with ML services. Our experts, Tom and Yuri, here are here to answer your questions. With that, back to you, Tom.
Actually, it's over to Uri. Over to you, Uri.
All right, thank you. So we discussed machine learning process at a high level. Now let's have a look at the technology and what are the machine learning services that we offer at AWS. We look at our AI and machine learning offerings as three different pillars, and they are the ones that consist of the machine learning stack. At the top level, we have the AI services, which allows you to easily add intelligence to any applications without really needing to know anything about machine learning or have any machine learning skills. Basically, these are pre-trained models for a variety of tasks or industry. Later on, Tom is also going to demo some of these services. The middle stack, which we're going to address a bit further on in this talk, is SageMaker, which is a set of managed services aimed to help you at every stage of machine learning development process. And at the bottom layer, we have the frameworks and infrastructure side of the stack. In this lower level at our machine learning stack is really offerings for the expert practitioners only interested in using AWS infrastructure. As part of that, we have our deep learning AMIs, the Amazon Machine Images, which are fully configured images with the latest versions of the most popular deep learning framework. With that in mind, let's take a minute to discuss cost a bit. If we look at the cost structure of machine learning workloads, we see that most of the infrastructure cost is on inference. And for those of you who are not familiar with what inference means, inference is the process of using a trained machine learning model to make a prediction. So most of the time we're using that model in production, so that obviously has an impact on the cost. But also when we're seeing more and more adoption of deep learning, which requires high performance compute like GPUs, we see that cost even increase further. So for that reason, we developed the Inf1 instance, the Inf1 instance types. It is powered by our Inferentia chip. This is a chip that we designed and built at AWS specifically to deliver performance at a lower cost. So now that we discussed the lower level of the machine learning stack, let's move one level up, which is SageMaker. SageMaker is a platform basically that hosts a set of managed services, as I said earlier, that are aimed to help you at every stage of the machine learning development. In a few minutes, Tom is going to have a look and those different stages and the different services for those different services. But before that, I want to just mention one of those services, which is Ground Truth. Ground Truth is a fully managed data labeling service. It's built for workflows to support annotating and labeling data for computer vision tasks, whether it's image classification, bounding boxes, or semantic segmentation. It also supports workflows for NLP. And there's one of the interesting things about it is that beyond the fact that you can leverage private workforces or public workforces, there are two very interesting features about it. The first is the annotation consolidation, which is the process where Ground Truth basically takes the same sample out of the training data and asks different annotators to label it. Thus, it improves the quality of the labeled data, but also prevents from any bias to influence the labeling process. And another interesting feature is the auto-labeling feature, which where Ground Truth is randomly selecting 10% of the data. It then tries using that 10%, which it asks labelers to label. It tries to predict some of the other labels or some of the other data in that training set. For those data that it has a high level of confidence, it doesn't ask to the annotators to label that data, but only for the low confidence. Thus, it really helps you reduce the labeling cost by up to 70%. So before handing it back to Tom, Padma, again, any questions?
Yes, we do. We do have some questions on the chat window. Thank you for your question again, RK, PHP, TNFL. The question is, in terms of known labels, does it support only supervised learning, or does it also support unsupervised learning?
So basically, label data is for supervised learning. The concept of unsupervised learning doesn't really use unlabeled data. If you think about it, unsupervised learning is the task where we're actually trying to find some underlying rules or patterns in data. So for that, it doesn't require any labeled data. So Ground Truth is really designed for supervised learning tasks.
I think that question was around SageMaker generally as well, in which case we do support unsupervised machine learning.
Yeah. Right.
Thank you, Tom and Yuri. Another question from Tom8242. Thank you for your question. The question here is, it's a two-part question. First, what's the difference between SageMaker Studio and SageMaker? And also, can I use one or the other if I have my own hosting environment?
So yes, first of all, SageMaker Studio is an IDE. It's an integrated development environment where users can interact with some of the services that SageMaker hosts, and it has its own features and its own services and offerings. And in a minute, we're going to go through the demo for Autopilot, which we're going to use Studio for that. As for the second half of the questions, yes, you don't have to take everything out of SageMaker. You can definitely pick and choose which services you want. For example, you can use SageMaker training to train a model, and then take the trained model and deploy it either on-prem or even at the edge. Or you can take a trained model that you even trained on your own laptop and deploy it into production as a SageMaker endpoint for real-time inference.
Got it. Thank you for that, Yuri. And everyone, let us know what other questions you have. We have Tom and Yuri here, who are the experts in this service. With that, back to you, Tom and Yuri.
Yeah, sure. Okay, actually, it's a really good question and a good handover to the next slide, which is where we talk through the capabilities and functions within SageMaker, of which one of them is the IDE, as Yuri said. But generally, SageMaker is split into 4 areas: prepare, build, train and tune, deploy and manage. I'm going to choose just a few of these to explain now so that we get the flow, because I know that Uri's demo is going to cover a majority of these. We've already covered Ground Truth. Data Wrangler is an interesting technology within SageMaker used to get that data prepared. So to take data from multiple sources, for example, and union it maybe, or maybe get it ready for a particular algorithm, you may need to do one-hot encoding or something like this. Once you've got your data ready and processed, we can just go into build and we can use a notebook for that. That notebook could be running within the studio, or it could be running in a SageMaker notebook, just a normal SageMaker notebook. So that's another difference, and also a similarity as well, going back to that last question. If I have to choose something here to talk through when it comes to train and tune, I will choose, actually I'm going to choose two things. I would say SageMaker experiments are used when you're doing hyperparameter jobs or running lots and lots of experiments when it comes to hyperparameters. This is where you fine-tune the parameters and values which you put into a training job. And sometimes you can guess those with experience, but sometimes it's appropriate to try all possible ranges. And then you do lots and lots of experiments, and maybe you need to go back and you need to have a vision of the experiments you've done in the past. And that's where SageMaker experiments is really useful. Another thing that I have to call out is manage Spot. There are a few workloads which are really particularly useful for Spot. What Spot instances are when Amazon has a lot of spare capacity. We have to enable the scaling which our customers demand. And when customers aren't using that additional capacity, we sell it to additional customers at a significant price reduction, up to 90%. You need to have those workloads be able to stop at any point or be batches, and machine learning is perfect for that. So if you want to save money, think how to use spots, and we'll quite possibly be doing additional sessions on this. Let's have a look now at manage and deploy. So one of the things which are particularly hard in machine learning once you've got your model is using it, and using it at scale. And with one-click deployment, you can deploy your model to an endpoint and your developers can call it instantly. Should that model need to scale up as your users use it more and more, then SageMaker can manage that for you. Keep an eye on this one here, SageMaker pipelines. It'll make an appearance on the next slide, where we talk about DevOps. DevOps is something we've learned in general development operations technology, is now being applied to machine learning. You need your development operations and your solution within ML to be secure. Security at Amazon is job zero. Everything we ship comes out first with security in mind. You may also have compliance needs. If you're working in a health science industry, for example, you might need to adhere to HIPAA compliance. You need that to scale, and you need your ML workflows. So we talked about, I mentioned pipelines, and pipelines are something which we've recently introduced to be able to take that flow where you do your data and then you do your training and you go all the way through to the endpoint and industrialize that so that you can do it on a daily basis and do it fast. And that's where ML pipelines helps you. You can also orchestrate jobs to over the night, for example, to detect drift in your model and relearn where appropriate. All of these tools are available to you. So I have the pleasure now of talking through the top stack. So he already talked you through the frameworks used by experts. He also talked you through SageMaker that gives you those building blocks. Services are fantastic because it's a stack on top that developers can call without any knowledge of machine learning. It's just an API. So for example, we have industrial AI services such as HealthLake that can be called. We also have vision. If you need to ask to feed an image into an API and ask, tell me what is this image? Tell me what people are in this image. Tell me if this image is safe to use at work. Then you can ask our recognition services, and again, we'll be demoing this later on. When it comes to text, we have Translate, Comprehend, TextRack, among others, where you could translate text or gain an understanding of it, do optical character recognition. And there's many more examples. And as we go to the right of this slide, you can see that you have the vertical solutions for healthcare and for industry. I recommend that you Google some of these tools if you're interested in the service approach. because they all have very unique offerings. Kendra particularly is very useful for enterprise search. Now, one last thing which I will talk about before doing the demo is talking about how our customers are using machine learning. So Bluevine is a financial company which was helping people within the COVID crisis, which still continues, but at the start of it, where Bluevine were taking in applications for loans from small companies, and they were manually having to read and understand forms. When COVID hit, the need for doing this stepped up a lot, and they needed to analyze thousands of pages of PPP loans per day. They were able to develop a solution that did this automatically within a week using Amazon Recognition, which again we'll demonstrate. And we'll be demonstrating that now. If you'll just give me a moment to change the share settings so that we can share the demo. Okay, so I'm just going to talk you through this. So first up, we're going to get some text. And then we're going to try and translate it using one of our services. We're going to use Amazon Translate. So here we're going to take this English text, which we took from the AWS website, and we're going to put it into French. I speak a little bit of French, and I can tell you that's close to accurate. I don't speak Greek, but with the power of Amazon Translate, I can try. I can also try with Hindi. And what I'm going to do now is try and translate back, which is always the test of a good translation system. Let's see how that goes. So I'm going to translate from Hindi back to English. And we can see the same or very similar text that we had at the start in English. For my next demo, I'm going to start the same, and I'm going to take some text. And I'm going to use Amazon Comprehend to try and understand the meaning of the text. So I'm going to do a real-time analysis. I'm going to take that text, and you can see that it analyzes it. You can see the entities involved. So you can see that Amazon is an entity, SageMaker. We can see the key phrases that make that up, including grouping, and we can see the confidence levels. We can see the application data, so the API would be called that way. We can see the language is very high certainty English, and we can see personally identifiable data. There isn't actually any personal identifiable data, so I'm going to add some. I'm going to add my own name, and I put it in an English way, so I'll put Thomas Coombs with, so it makes sense to the ML system. And you can see now it's identified myself, my name, as PI data. We can see that the sentiment is neutral. It's just a technical paper. It's not meant to be positive or negative. It's slightly positive. And we can see the syntax where my name is a noun, and all of the other words. This can be used by developers to really great advantage. Let's move into some image. We're going to do some image and scene detection. Here's a picture of a mountain. Let's see if it knows that. It sees that there's a field, Greenland, outdoors. If we look at the response that came back to the developer, we can see the confidence. We can see any parents, i.e. grass, which might be on the ground. And now we're going to try some facial analysis, and I'm going to use an image where you can see my daughter has had a scribble on my face, and I haven't managed to escape. You can see that I appear to be male. My age range is 37 to 55, harsh, being I'm 40, but it is right. I'm not smiling. I do appear to be calm. You can see that the response, it can show you the confidence of other things like having a beard, my emotions. I'm kind of happy. I'm a bit confused, obviously. And you can see the coordinates of where my eyes are and where all of the artifacts are within the face. Let's do a comparison. So let's compare my face to my face and try and make it as hard as possible. So we've got the makeup, we've also got the helmet now, and you can see that the system has seen that there's a 99.9% chance that those two people are the same person. And we did all that without any ML experience. So the last thing I'm going to show now, I know there's the last but one, is having a look at text within an image. So here's a local sign in my village. You can see Rue de l'Église, and you can see that the cabin is that way. And it's detected that text. One last thing that I'm going to show is PPE detection. We see a lot of this needed these days with the COVID crisis. Here's a picture of me without a mask on that's just detected I have a head. But here you can see that here it's detected a face cover over my nose. So this is helping people. This is helping businesses work with machine learning in the COVID crisis, and we're seeing a lot of use of that. So with that, I'm going to hand over to Uri, who's going to do the demo of SageMaker Autopilot.
Awesome. Thank you, Tom. Thank you for that demo. And with that, we're going to go through the demo of Autopilot. Autopilot is our AutoML solution. It's SageMaker. AutoML, as the name implies, it's an automated process to develop machine learning application. And in this demo, we're going to create a machine learning model automatically without writing any line of code. We will train and deploy a machine learning model for predicting whether a customer will enroll for a special savings account in a bank. For that, we're going to use a publicly available data set, which is going to contain some information about the customer, some demographic information, responses to marketing events, and some external factors. So with that said, what you see here on the screen right now, this is the SageMaker console page. At the left-hand side, you can see the different services that we mentioned earlier. Some of them I'm going to show in a minute. And we're going to log into the SageMaker Studio UI. As I said earlier, the SageMaker Studio is a IDE. It's an integrated development environment. One of the components there is a Jupyter notebook. We'll log into that in a second to launch our job. You can choose from different types of kernels to run the notebooks, Spark environments, R environments, and so on. So here I'm going to first download the dataset. This is a simple API which executes the code to download the data. Just for the sake of this demo, we're just going to briefly have a look at what that data consists of. So you can see here the different features, the different columns that we're going to use in training. And I want to bring your attention to the last column, which is labeled as the Y. This is going to be the target feature that we're going to try and predict. So right now you can see only no, but there's some yes. This is whether that specific customer joined the savings account or didn't he. This is what we refer to as a binary classification problem. And before launching the autopilot job itself, I'm just going to upload the data to S3. In this case, I'm not going to configure a specialized bucket, so it's going to use the SageMaker default bucket. Again, everything is there designed to help you move along, so you can use the default bucket and upload your data to. Next, I'm going to use SageMaker experiments, which offers a structured organization scheme to help users group organize machine learning through the iteration. And I'm clicking on create the experiment. This is going to be an auto ML experiment, so I'm giving it a name. As a good practice, I am putting in a tag there. I'm going to configure where my data resides. So I'm going to copy the path from S3 where I previously uploaded the data. Just putting it here. Then I'm going to need to configure the target column. And again, as I said earlier, what is the label for the target feature that we're trying to predict? And in our source dataset, it's labeled as Y. So I'm putting in a Y here and configuring the output path for the artifacts that the AutoML autopilot is going to generate. Again, I'm just going to use the same path, and I put an output at the end of that path. Next, I'm going to help SageMaker's Autopilot understand what is the type of problem that we're trying to solve. As I said earlier, I'm going to use the binary classification because we only have 2 classes, but you can see we have other types of a problem that we can tackle, whether it's a regression problem. Regression means it's a numeric prediction, or a multi-class classification when we have more than 2 classes. Another thing that I would need to configure is the objective metric. And if you don't know about that, I suggest you read about it a bit. For the binary classification, I'm going to use the area under the curve metric, the AUC, and I'm going to launch the whole experiment. And that's it. I'm creating the experiment, and from here on, there's no more action required from my side. You can see that already, and I'm pausing it for a minute. You can see that Autopilot already is visualized the whole pipeline, the whole process that we're going to see in a minute, the pre-processing, candidate definition, and so on. I'm going to fast forward for the sake of this demo a bit, and we're going to see where already Autopilot is already at the feature engineering stage, but I want to draw your attention to the upper right corner. So we're going to have a look at some of the candidate and generated code that Autopilot has had. And the reason for that is both, so you can use Autopilot and use the generated code both to customize whatever you need, but also to gain full visibility into the process underneath. So you can see here that Autopilot generated the code that now explores the data. It looks at columns, whether there are categories or strings. It is going to look into seeing if we have some missing data there, and also provide some really basic statistics about our data, like the mean and median and so on, which you can also import. The other generated notebook is the candidate definition notebook. This is basically going to help you run, if you want to run it, the training yourself. So you see what are the different environment variables that it's using, what are the paths that it's going to use, and also it's going to, you can have a look here and see what are the actual algorithms that Autopilot is going to test. So you can see here we have XGBoost, linear learner, and also a multi-layer perceptron, which is a type of deep learning algorithm actually. So that said, Autopilot moves to the next stage, which is model tuning. So it looks at the different algorithms and see which one it performs best, but it also has a high parameter optimization job, which you can see that job specifically is trying to even make it one step further, where it takes each algorithm and fine-tunes that to get the best possible results. And you can see here that these are the different hyperparameter jobs that are running. They're already in progress, and we can once we go back to the Autopilot studio, you can see already that we have different different jobs which are already completed, and we have already a candidate. This is right now the candidate with 0.95% accuracy. And if we look a bit further in, we can see some information about that model. So it's using the XGBoost algorithm. Again, it's the binary classification, and you can also see some of the metrics and objective scores that it's using in that process. And with one click, I'm clicking deploy model, and that's it. I'm moving now to deployment of that model into a real-time endpoint. This is used for, as the name implies, for a real-time inference. I'm going to give it a name. Let's just call it a demo AutoML. I choose which instance one run the endpoint on. I can configure the number of. So, for example, some of the notions of a managed service is that if I configure 2 instances, SageMaker will endpoint will automatically deploy them into different availability zones. So you're available out of the box. You can also configure it to save some of the requests that are coming in, some of the predictions generate later on, analyze them, and see how to improve. Finally, what is the type of response that the service is going to give back? It's or the actual label for the model. And with that said, that's it. I'm clicking deploy, and in SageMaker endpoints, I can already see that it is in the deployment phase. One last feature that I want to bring your attention here is another service that we have, Clarify. Clarify is a different service that we have in SageMaker, but it's integrated into Autopilot. It's a bias detection and model explainability service. You can see here in this graph the different features that are model generated and their importance. So here you see the top 10 features. And if you look, for example, the last feature here is age. And it does take that into account, but our model doesn't give it a lot of importance. And it's important to see that our model is not biased by the age or people applying for this savings plan. And with that said, before we move on, any questions?
Before we do that, Yuri, you were cutting out a little bit there, so I'm just going to recap what you achieved there. So we used SageMaker Studio there to run an autopilot job, which called a number of AWS core services. We took data in from S3, we manipulated it, we trained it, we ran various hyperparameter training jobs, and then we deployed our model. And then we checked we used Clarity to check for model bias, which is extremely important in machine learning remit. So let's. I think we've got some questions coming in. Padma, over to you.
Thank you, Yuri, for the great demo, and thank you for the recap, Tom. Question for you, as you were building the demo, and this question comes from Tom A242. Thank you for your question. As you built this demo, you mentioned that you had little ML experience. Can you talk a little bit about your experience building this up based on your limited experience, and talk about how SageMaker and the documentation and all that helped you getting started quickly?
Yeah, happily. Okay. So yeah, I've used all of the stacks of the machine learning stack there, but luckily the demo that I gave there, I didn't need any machine learning experience because I was just calling APIs. So I'd answer your question twofold. One, why is it easier? Sorry, I'll start again. How can you use SageMaker to make your deliveries within machine learning easier? One, you can use services. Services are just APIs that you call, and in the background, Amazon has done the work which trains the model and deploys it, so you're just calling a service. And then on top of that, SageMaker makes it easier for you by giving you lots and lots of tools. So what you have available to you with SageMaker, for example, are Amazon algorithms that you can use. You have all of the infrastructure for deploying those images and scaling those images in Docker. You have the ability to use pipelines and all of those other subtools which I explained in the 4-stage process. All of those things, if you didn't have SageMaker, if you were using the middle of the stack and not the services, you'd have to do yourself. And that's why it's really hard, and that's why it makes it a bit simpler. But really, if you have no ML experience and you don't want to have ML experience, but you do want to use ML services, that's what the AWS ML services are for.
Thank you for that, Tom. And back to you.
Sure. Okay. So now we've gone through some examples of how we can use machine learning as customers. We want to talk through how we can help you in enterprise support even more. So just as a quick recap on what enterprise support offerings we have. We have 4 levels, basic, all the way up to enterprise. We recommend that if you have production workloads running, you use business or enterprise. As you go from dev to enterprise, you get faster possible response times on your critical situations, which a lot of customers see as or need if they're supporting business critical workloads. If you're business or enterprise, you also get the support API, which our customers use to automate their processes, like creating tickets based on access to ticketing systems and things. But there are a few parts of the enterprise plan that I'd just like to bring to your attention. One is the infrastructure event management, which is where enterprise support helps you de-risk your really key releases and times of year. So, for example, we'll start 6 weeks before, ideally, and we work with you to de-risk. We'll work through all of the limits on your accounts. We'll work through your architecture. We can do well-architected reviews and operations reviews. We can do those at any time as well. That's part of the enterprise offering. And one of the things that you get with enterprise support is a TAM, and that's how you get a me as a technical account manager allocated to your account. One of the things that we're going to talk about now is specific to ML, though, and this is something which is really exciting to us within the ML sphere. We have a new proactive service, and Uri's going to talk you through that.
Right. So we've just launched the proactive services. These are services that drive operational excellence for customers by providing prescriptive recommendations about their workload. These are engagements that are delivered by AWS support experts. They are included in the enterprise support plan. Last September, we launched the first phase of those services. It contained services for analytics, containers, and databases. And we've just a couple of weeks ago launched the second phase, which also includes security, networking, cloud operation, cost optimization, and obviously machine learning and AI, which is what I'm here to talk about a bit. So in the machine learning and AI offerings that we've launched, we really designed them to help you or help the customers take their machine learning workloads to the next level. So we have 3 offerings in that space. The Amazon SageMaker operational review, which is based on the well-architected machine learning lens, where we were evaluating your machine learning workloads against operational excellence, reliability, security, performance, and cost optimization best practices. And at the end of this engagement, we give you a set of recommendations and highlight some of the ways that you can optimize your workload. The second offering that we have is the SageMaker cost optimization session, again, where we analyze your usage patterns and we try to optimize you for cost so that you're paying less for your work, for the machine learning workload that you're using. And finally, we have the machine learning operation, the MLOps workshops. It's really designed for customers to move from individual projects to streamline machine learning applications at scale. For that, we use SageMaker pipelines, which Tom mentioned earlier. We're using these pipelines to create, automate, and manage machine learning workflows, where we simulate basically 3 teams. We have the DevOps teams, the engineering teams, and the data science teams to finally deploy and configure a full pipeline to automate deployment of a machine learning model. And with that, I think I'm almost done. Any questions?
Hi, Tom. Hi, Uri. Thank you
Hi,
so
Todd.
much for the great talk today. There are no other questions on the chat window. So I have a question. Is there anything else you want to add before we go?
Yeah, I would just add that the power of the cloud to me as a developer, a long-term time developer, is being able to try things. And I managed to put these demos together very quickly, and all of those demos you could try as customers for free using the free tier. Everything I did you could do for free, and a majority, I haven't worked out exactly how much it would cost to do Uri's demo, but I would guess it would be very close to free. So do do have a play. Use the free tier and play because it's fun.
Thank you.
Right. So maybe just to add on that, none of the services that we offer here requires you to pre-sign or any upfront costs. You're really built on what you're using, and as Tom said, we have a free tier for that. So testing and really, and if you need any help, then just reach out to one of those specialists. That's what we're here for.
Thank you, Tom and Yuri. Everyone, today we looked at Introduction to the AWS Suite of ML Services. Thank you to our moderators for posting the registration page for our upcoming episodes, awssupportsyou.splashthat.com. Please bookmark this page, and we hope you can join us on our next episode. If there are questions that were not answered today, please post them on forums.aws.amazon.com and email us awssupportsyou@amazon.com. Please send us any feedback and tell us what else you would like to hear about on this show. Thank you for joining us today at AWS Supports You, and happy cloud computing.